Program is about to commence in a few moments. Before we begin, we would like to remind you to mute your microphone to keep the audio channel free of clutter and available to the speaker. Please use the raise hand function or chat when you want to speak. And all attendees are also reminded not to leave the meeting until the program is over. All attendees are requested to use the virtual background previously shared. Your cooperation is highly appreciated. Thank you. Bismillahirrahmanirrahim. It is an honor for me, Farawahida Muhammad Noor, as your moderator to host this special program. To all honorable guests, speakers, and students from Politeknik Sultan Azlan Shah, PSAS, Malaysia, and Politeknik Negeri Bandung, POLBAN, Indonesia. Assalamualaikum warahmatullahi wabarakatuh, and very good morning. First of all, I would like to welcome all of you to Harnessing the Power of Nature Go Solar Education Program, a collaboration between Politeknik Sultan Azlan Shah, Malaysia, and Politeknik Negeri Bandung, Indonesia. For everyone's information, program today is participated by the students from Politeknik Sultan Azlan Shah, Malaysia, and Politeknik Negeri Bandung, Indonesia. Ladies and gentlemen, we will proceed our program this morning with some sharing from Politeknik Negeri Bandung, Indonesia. Without wasting our time, we would like to invite the first speaker from Politeknik Negeri Bandung, Indonesia, Professor Dr. Insinyur Hermagasantos Zein, to talk and share his knowledge about technical aspect of integrated photovoltaic and hydroponic systems for rural area. Respectfully welcome Professor Dr. Insinyur Hermagasantos Zein. Please welcome.
Okay. We want to start the presentation.
Please welcome, Prof.
Okay. We start the presentation. You hear me?
Yes, we can hear you.
Okay. Now, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. And now I want to presentation about the technical aspect of integrated photovoltaic and the hydroponic system for rural area. I'm from the Energy Conversion Engineering Department, State Politeknik of Bandung, POLBAN, and location in Geger Kalong. This is my identity here. Okay. What the problem of the hydroponic? Hydroponic is need for the vegetable to the community the had use for the rural area. Production land of the urban area is limited because the land of the area of the become small because the infrastructure for the resident on the other activity. Hydroponic well and they become the future potential vegetable because it's growing very fast for the soil plantation. The Indonesia, the problem the rural community is a government goal to the employment. Many rural area not yet connected to electricity grid because this is for the far from the grid. The problem how to the rural area to have the energy. Solar energy in Indonesia is potential because it is equatorial site. This paper proposed to design integrated photovoltaic hydroponic system in developing rural area. To design implementation, the 5 state and the 50 spot per state is feasible to commercialize. This our formulation. The model integrated photovoltaic This is we have the device to the system. Okay, this is a system of solar cell system. This is system hydroponic. This is you can the flow for the power and the blue the flow of water. We have the panel, solar panel control, and you can battery. This is a battery, and the pump, and you can the hydroponic reservoir about it. This is for the hydroponic system. I will say the water vessel and the plantation and the you can the reservoir and they can the for the farm and they flow the water when here and they need the nutrition for the plantation about the available like that. And that's how the generally for the power system solar, we have the solar number one, number is can the control, and number three is battery, this measurement, and by is computer. With the fungsi of the computer, we have the change to the DC system to AC system for the panel absorb the solar power. You can the solar for here can they from the solar can they absorb the energy for the DC system and they store in the battery. Okay, what the panel of the solar cell and solar cell material is a semiconductor. A semiconductor concept, we have the silicon. In the silicon is a covalent bond, and this is covalent bond about it. The one electron out this covalent bond, we say the free electron. The empty space of the electron integrated, we say the hole. We say the concept of the hole. This is material get the energy from the photon. Another, we have the two type of the material. The material N type, which is double the phosphor. We say phosphor has the 5 electron valency. The one electron not bond. One electron not bond, we say the free electron. And another type of the semiconductor is TPP. And they can get adopt this boron. And the boron is F the 3 electron valency, one no one valency bond, one empty space. And in space we say the hole. And generally we have the free electron for the TPN, and he say the donor material, donor semiconductor, and TPP is have a hole and there's acceptor electron. Okay, and what is the band energy for the material? The concept of the this is donor. One electron out for the specified jet, which is become the we can this p electron about it. And the promotion to the get the photon and the electron go this free electron. And then about the p type and the electron is empty space for here, which is flow hole material. Okay. They from the energy from the radiation and the process radiation absorbed by the atom or molecule for the semiconductor, and this is atom the energy continue and absorb the excitation of atom of this oscillation of atomic molecule, etc. You can say this is photon energy, which is atom, which is second the such or ionization occur, where the wavelength about the C, velocity of light, Mach Planck constant is the energy electron. And then ionization energy, you can get the wavelength about like that. And then wavelength or radiation about the 1250 Armstrong is capable to cause the photoionization gas. Okay, this is made from the material. The material from the get the PN junction. This is TP is TPP and the TPN. The flow of all the right and the flow the electron to go to left, and current flow is from to left about it, and then you can the conduction from it. And they get this electric charge for here. We have the energy for the solar. Okay. Now, for the solar panel, the solar panel is production for the die, and not all. This is for the die, and for this curve like that. And the effective policy here is no solar light. Okay, and this is our calculation, and you can the modification for the effective of the solar to the set of the battery production body, and you can the energy period, and you can the start calculation like that. And then the area calculation ratio, you can say I apply to the ratio for the Cianjuang integrated photovoltaic. In Cianjuang we have the solar, and this is plantation for here, hydroponic, and this is sophisticated. The calculation ratio like that. And this is you can relation, and you can relation is about the coefficient 70, and this you can battery like that, and you can the optimal image to the available component in the market. Okay. PSAS hydroponic and plant 5 state and 50 state 8 need the pump 25 watt, and they flow the water 4 liter per minute. Effective some light about the 8 hours per day, and you can the system absorbed by electric and 720 watt hour per day, and you use a PP panel 2 times 50 watt panel. Assume the remain energy 30% because this is efficient. You can drive the motor. Okay, below the 30%, it net can drive the motor. And the calculation correction and use is 1.2, and the calculation ratio for the net battery, and the about the 12 volt and 45 watt. You can the two battery. Need the two PV panel 2 times 50 watt. And the economic analysis, you can the payback period and 30.5 month, and CCP, and return of asset about the 8.01, and result indicated the system is a bull by quite visible developing the rural area. Okay, hydroponic plantation can afford the future agricultural technology, Hydroponic can trigger rural economic development by opening up the employment opportunity for rural area. Hydroponic needs the circular water continuously, and the system solar cell and hydroponic have been present in the people. The causality for the size 5 multiplied by 15 spot in the Jiangjuang, West Java, require that uh, 25 farm, 20 watt 5 farm, and the 2 panel 50 watt, and the 50 liter reservoir, and then you can need 2 battery capacity 2 volt, 45 hour. And then result of the study based on the economic aspect, maybe is a focus, say, Mr. Connie to next the presentation, how to get the economic a good position. And result indicated the system will liquid feasible to develop rural area. Okay, the explanation of the economic maybe the next presentation by the Mr. Connie. Thank you for your attention.
Thank you very much, Professor, for the very interesting presentation. So now I would like to open for question and answer session to all audience. Do we have any questions to Professor? Prof, I'm interested in this project. I would like to know, is there any requirements for the rural area to ensure that this project is a success? I mean, should the rural area need to have how much sun exposure or any requirements for that?
Okay, the rural area is for success the project. We have the good solar. Indonesia, the solar light in Indonesia is very good. This is side of equator area. The problem, rural area far from the grid. Okay, this is no energy for rural area. It is problem for rural area Indonesia. Uh, the alternative one is uses solar system. Solar is easy, and the bull or solar. But the solar not the mass power. It is a small power. Can you look it and it only the about the 100 watt. 100 watt and is enough to the 2 PP panel and the capacity of the 50 watt hour. And the successful the area in the for the small area and need the grow for the plantation or hydroponic. But the hydroponic a good plantation compared to the soil plantation. And the next reset for the California, the hydroponic plantation grow about the 50% height from the soil plantation. This is with the problem Indonesia can they employ for the rural community to the to the uh, to the rise your economic and the vegetable use of Indonesia. Okay.
Okay. Prof, I would like to know if you are using the solar energy for planting vegetables, economical wise, will it cost high price for vegetables? Uh, can you comment about that? Mm.
For the success of public or for the success or project, we have the study for the mechanical aspect, technical aspect, and economic aspect. And what the technical aspect, how to they will optimize the component as suitable to the requirement of the hydroponic your design. Okay, the is implementation of the mechanic technical the big implementation is not good, not optimal. How to optimize the uh, technical, how to optimize for the solar cell, battery, and other equipment, and to record over the hydroponic. Now, after we have the optimal technical aspect, and then you can optimize of the economical aspect. Okay. This is for the success for the project of hydroponic uh, uh, hybrid from the solar.
Okay. Do we have any other question from the audience, students? No. Nobody doing project on solar? Okay. What is the benefit of hydroponic? Yeah, Prof, we have a question from our student here. She's asking about the benefit of hydroponic.
Benefit improvement for the study of the economy by Mr. Coney, and this is feasible. Feasible for the hydroponic combine of the solar cell. This is benefit can production of the vegetable become rice, and the can you use this plantation as a good plantation, the good price. Okay, don't you use the plantation as a low price and not the economical. Example, you choose this by the our test for the Indonesia is say the kangkung vegetable. And this is for the high price and the market. This is become the economical for the you use this you use after you use economical or technical aspect optimize, and you choice is vegetable. How the vegetable is suitable for high price your country. I don't know Malaysia what the vegetable and the sweet met for the hydroponic. Maybe like that for you.
Okay. Prof, but not vegetables are suitable for hydroponic, right?
Yes.
Okay.
Please you choose the plantation vegetable for the hydroponic and the good price. Okay.
Mm,
And the proper
okay.
price. My
Okay.
test. The methods of the is we have the 30.5 period feedback period in
Prof, this
economic.
is only for the research purpose, right? So we have only 5 times 5, 25 pots, right? For the hydroponic, if I'm not
Yes,
mistaken just now. 5 times 15 spots. Okay.
5 times. Yeah, 5 times 54. You can the test begin is one stat 1, 2, 3, 4, 5. Once one vessel bought it, it's 15 vegetable spot.
How much does it cost for this 5 times 15 spots?
Maybe mungkin answer by this Mr. Connie. This is not
Oh,
my
so we
this,
will be with Mrs. Connie this evening, right?
yeah, to next your question and present detail for the Mr. Connie.
Okay. All right.
I have uh, uh, how many water uses is palatable. He say for me is water for the 4 liter 8 minutes. 4 liter 8 minutes use a pump about the 25 watt. And then I calculation for the component, and the after calculation percent and suitable for the component in the market. Example, we have the PV panel 90 watt and use PV panel 2 times 50 watt in it. Okay, this is for the question for you economic. Maybe the answer, Mr. Pony, for the next slide. Okay, the presentation.
So, so my last question, do we have any question from the audience? Or maybe from POLBAN students? We don't have any question from POLBAN student. You can also chat in this chat so that we can read your question here. No more question? Okay, to all participants, you are kindly requested to fill out the attached form in this chat form. Please fill up the form for your attendance. Okay, thank you very much, Prof. It's already 10 a.m. So we will have our break and we'll start program at 2:30 p.m. So till then, we will meet you again. Thank you very much to all viewers and participants.
Thank you. Thank you very much all. Good morning. Okay. Okay, Pak itu positif. Excuse me, Mr. Paragat. Excuse me. I wanted about talking with Miss Asliza. She want to my contact. You can see my contact in the my slide.
Prof, you can type in the chat comment.
Chat di chat. Apa di chat? Dari mana? Sebelah kanan bawah. Mana? Ini. Ini.
Oh, Bapak mau nulis yang kontak aja tak pilih
Ini.
telepon Bapak
Ini.
Ya,
Di sini.
nomor telepon.
Nomor telepon langsung.
Iya.
Phone kontak.
Phone kontak aja. Kontak.
Nih. Okay, I have right in check. Thank you.
So all participants may leave this session. So we will meet again at 2:30 p.m. 2:30 p.m. Thank you. 2:30 p.m. Malaysia time.
Indonesia time. Indonesia time.
Okay. Okay. So Indonesia time will be 1:30 p.m. So Malaysia time we will meet again
Bye.